Hey there, this is Pat, and I'm going to be making a video on how to perform the project for Dr. Kim's 418 project for spring 2022. Now this project overviews how to perform the finite element analysis on the Red Wing, which is donated by Professor Martin, and you guys should have seen in LB184. Now I have prepared this project in such a way that it should be fairly simple to follow in terms of um, a lot of the nitty-gritty details for FEA, just so you can get a good handle as to how powerful FEMAT can be and the functions that are available to you. So let's start by importing this FEMAP neutral file. If you have it downloaded, you can also open it. But here I'm showing import FEMAP neutral, and let's open up the file. So we're going to press OK. And we're going to see this structure right here. Now what we're looking at is the internal structure as well as the skin, if you notice the semi-transparent panels on top of it, of the Red Wing. The ribs are the ones in red, the spars are the ones in yellow. We have some of these curves over here. These are the flanges, this long curve over here on the top and bottom. These are both stringers, and we have a truss structure right here. All right, so what do we want to do once we have the file imported? We want to create our material properties and follow along with the process, just like we've done in the past. So let's start with model, material, and let's select 6061 aluminum. So the entire structure is going to be made of 6061 aluminum, so after we press OK, we can kind of forget about that and move on to the next part. Model property, we're going to be defining the plate elements. Now, we do have 3 different type of plate properties that we're going to be dealing with. And while the ribs and the spars, as you're going to find out right now, are going to have the same thickness, for bookkeeping purposes, it's still proper to keep them separate in case you want to change one or another. And that's actually going to come into play later on in the project as you guys see the impact of changing the thickness and whether there's a certain trade-off or whether it becomes negligible after a certain point. So let's start with the skin. And this one's going to be actually 0.025 inches. Okay, then we're going to start with the plate property that defines the spars. Now it's going to be 375. Same thing for the ribs. Now, finally, we do want to deal with these stringers, flanges, and that truss structure. And them being line elements, we can't use plates for them, so we're going to be using rods. So it's going to be stringers, flanges, and truss. For this one, let's do 0.1 inches for an area, and press OK. Now let's cancel. So having those created, now we want to get to meshing this. So one of the things that I prepared for you guys was the grouping of this geometry in different layers, as well as the determined spacing for these curves so that when we mesh it, we all get a consistent mesh that we're going to be able to follow along with the instructions. So what are layers and why did I prepare them like this? So layers are just groups that you can create in FEMAP that are separated and you can actually toggle on and off. So as you can see, I'm turning on and off different geometries. And this is going to help us when we're meshing because if we want to isolate the ribs, just to mesh the ribs, we can start that and activate by double clicking this rib nodes and elements. So whenever we create something, it'll now go into this layer and keep it organized. And once we're done, we can turn it off and move on to the next one. So starting with the ribs, mesh, geometry, surfaces, and let's select all of these surfaces on these ribs. Now you might be asking yourself, why are the trailing edge cut off for some of these ribs as we move towards the tip. And that's actually because that's where the aileron um, is located. And we're performing a finite element analysis of the main wing structure without this aileron. So let's click Show Selected to make sure we've selected everything. And if it highlights yellow, that means we have. So we press OK. We select. These are the ribs. And we press OK. Right. So now let's turn off the geometry. Move on to spars and double click it to activate it. We're going to mesh, geometry, surface, time, show selected, bars. Now, let me turn off the geometry for a second and turn back on these rib node elements. What do we notice here? There are certain nodes that are shared by both the ribs and the spars. And for a proper finite element analysis to be performed, this has to hold true because each element is defined in its boundaries by the nodes, and then the element that contains the certain stiffness matrix is calculated at the each end of the nodes for its deflections and its stress, and then that's translated onto the next element. That's how computational analysis works in FEA and CFD. So if we actually have elements that aren't connected via nodes, then we're going to be getting weird behavior, and we might see that in a second. But for now, let's move forward. Let's turn on the skin. And one thing to note about the skin is you have these transparent or semi-transparent panels, and you have these green empty squares. Now these green empty squares are boundary surfaces, which are just slightly different than regular surfaces, but for the time being, let's not worry about that. They're going to function just as intended. So mesh and select all these surfaces right here. So it can get a little visually cluttered. So always remember, if you want to check what you selected, you can use the show selected and move forward with that. Now, if you notice, boundary surfaces are going to show their boundaries as yellow, but the internal is going to be clear. So take note of that when you're selecting all your things. All right. And now that we have everything selected, let's press OK. Yes, we want to mesh the boundary surfaces. We select the skin, quad mesh. We say OK. Right. And then one last thing that we mesh separately is this trailing edge right here. We have boundary surfaces right there, very small. So let's mesh geometry surface, select these boundaries, press OK. That is also a skin. Let's do a tri mesh for this one. Right. So that's a nice mesh right there. Now again, if we notice, there are certain elements that seem to not have nodes, and what's happening there actually is they're present in the rib layer. So the connectivity, because of these nodes, is super important, and it's very, very crucial that they're there, and they show up just like they do right there. And when we turn it off, clearly see the connection right there, so that's good. That's everything we need. Now, one thing we do have to fix once we mesh that arises every time, small gap right here. We have some elements forming or some gaps forming sometimes, and we got to get rid of that. So let's zoom fairly close, wiggle it so we can isolate it visually. Now what we're going to do is we're going to check our geometry, or check our nodes. So when we used to merge coincident nodes, we'd select all and just use the given tolerance. But in this case, we want to make sure that everything that's close by and maybe just slightly farther than usual also gets merged together. So let's pick using a polygon. Selecting it, so that's good. And let's up this tolerance from 0.015 to 0.5. dot, 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 and press OK. And it says on the bottom 66 nodes merged, and I believe the computer, because here you can see very clearly that now where there was a gap or some weird wonky geometry, they're connected. And one thing that you should note, however, is it's not going to be perfectly linear. There are more sophisticated methods of doing this, but for the sake of simplicity and being able to follow along easily, this is the easiest way. So let's leave it like that.